So in this video, we'll be discussing the average molar mass and Dalton's law of partial pressures. So these two parameters are a consequence of the ideal gas behavior. So madali silang ma-derive from the ideal gas equation. So for the average molar mass, that is the molar mass of your mixture. So denoted by the equation. So that's the mole fraction of each gas component multiplied by their respective molar masses. So ano yung mole fraction? So the mole fraction of component I is equal to the number of moles of component I over the total number of moles of the components in the mixture. So kung marami kang component, that's the mole fraction of each component. Okay? Yun yung mga mole fractions niya times the molar mass of those components. Okay? So, yun yung makukuha mo doon, that will be the molar mass of your mixture. So, next is the Dalton's law of partial pressures. It states that the total pressure of the system or a mixture of ideal gases is just equal to the sum of its individual pressures, and as if they have their own containers. So, kung nag-exert ng pressure si gas 1, and gas 2 and gas 3, you just add their individual pressures or their partial pressures. So those are partial pressures, okay, para makuha mo yung pressure ng system. So this is the Dalton's law of partial pressure in terms of the pressure of the individual components. And this is the Dalton's law of partial pressure in terms of the number of moles of each component in the system. So, we will assume here that the system or the gases in the mixture are contained in a single container which has a single temperature. Okay? Tapos pare-pareho yung volume nila kasi pare-pareho din sila ng container. So, that's the same temperature and volume. So, i-add or i-relate lang natin dito yung pressure dun sa number of moles ng gas. Since hindi naman nakadepende yung kanyang behavior or kanyang state functions like pressure, temperature, and volume sa kanyang identity. Okay? So, for the mole fraction, so for any gas I, okay, so the pressure of gas I is equal to the number of moles of gas I times R, which is the gas constant, times T of the system over the volume of the system. That is the mole fraction of any particular gas component sa isang system. So for a system with many ideal gas components, so i-add mo lang yung pressures nila, that would be the Dalton's law of partial pressures. And then if they are in the same container, which they should kasi sila ay mixture, you can separate the temperature and the volume of the system, okay, using the equation P is equal to N RT over V. So, ito yung mga N ng gases na yun. Okay? So, you can add the number of moles, okay, times R times T system or the temperature of that whole system over the volume of the container kung saan nakalagay lahat ng gases. So, the N total is equal to N gas 1 plus N gas 2 plus N gas 3, etc. So, yun yung total number of moles ng gas. And the total pressure is equal to the N total, which is this, okay? This is the N total, sum of the gas. So, therefore, N total is equal to P total V system over RT system. So, dito naman, P total and total, ganyan din yung yung nakalagay dito. Okay? So, if you want to get the total number of moles, you just have to use this equation, okay? Using the total pressure of the system. Kung gusto mo naman makuha yung total pressure, you just add the number of moles of the system and use this equation. So, you can derive the equation from the other. Okay? So, how do you get the mole fraction? So, the mole fraction is the number of moles of each component or a certain gas component I over the total number of moles. So, kung papalitan natin siya ng mga parameters na to based on the ideal gas equation, you'll see that the V over RT system ay magka-cancel. So, pag nag-cancel sila, it will just be equal to P gas over P total. So that's for your mole fraction. So therefore, the mole fraction is equal to P, or mole fraction of I is equal to the number or the pressure of component I over the total pressure, which is also equal to the number of moles of component I over the total number of moles. So that's for the mole fraction. Sample problem. So 0.5 moles of O2 plus 0.75 moles of N2 is placed in a 4.00 liter container at 25 degrees Celsius. So letter A, calculate the partial pressures of N2 and O2. So, madali lang siyang kunin dahil meron tayong mga number of moles of each component. So, kunin muna natin yung individual pressures nila. So, for O2, the pressure of O2 is the number of moles of O2 times RT over V. The temperature is 25 degrees Celsius. So, you'll just have to convert to Kelvin. Okay, so that would be 298.15 Kelvin. That's 25 degrees Celsius. Then you have this volume. So if you calculate the pressure of O2, you'll get 3.058 atmospheres. And if you calculate the pressure of N2 using the 0.5 moles, you'll get 4.587 atmospheres. So all you need to do is to add those pressures to get the total pressure of the system. You'll get 7.645 atmospheres. So letter B, calculate the average molar mass of the mixture. So all you need to do is to calculate the mole fraction of O2 and N2. So meron na tayo nung total number of moles. Okay? 0.5 moles plus 0.75 moles equals 1.25 moles. So yung 1.25 moles, that's the N total. 0.5 moles is the number of moles of O2. So that's 0.5. This is NO2 over 1.25. So you'll get 0.4. So check natin, 0.5 yung O2. So sa N2, you'll just have to divide 0.75 over 1.25. You'll get 0.60. So calculate the average molar mass of the system. So meron na tayong mole fractions ng O2 tsaka N2. All you need to do is to get the molar masses. So the molar mass of O2, oxygen gas, is just oxygen, 16 times 2, that's 32 grams per mole. N2 is 14.01 times 2, that's 28.02 grams per mole. So 0.4 is the mole fraction of O2 times 32 grams per mole, plus 6.6 is the mole fraction of N2 times 28.02 is the mole fraction of N2. You will get 29.612 grams per mole as the average molar mass of the system given. Okay? So another sample problem. 1 mole of a certain ideal gas was expanded isothermally from 0.5 liters to 2.00 liters at 30 degrees Celsius. Calculate the pressure change due to the expansion. So, makikita nyo dito sa side na to, the pressure is not given yung initial volume and initial temperature. Ang nagbago lang dyan ay yung volume. So, the temperature didn't change. So, masasabi natin na this is an isothermal. Okay, isothermal process. So, the pressure changed isothermally. So, hindi rin naman nagbago yung number of moles ng gas. So, we can actually use Boyle's law in the situation. However, let's calculate the initial and final pressures first. So, to calculate the initial pressure, you just use the P equals nRT over V derived from PV equals nRT. So, P1, that's the initial pressure here. Okay, is equal to 1 mole times the gas constant 0.08206 times 30 plus 273.15 to convert the degrees Celsius to degrees Kelvin over 0.5 is equal to 49.753 atm. So, to be able to get this pressure, or P2, you need to use Boyle's law. So, Boyle's law is P1V1 is equal to P2V2. Okay, so therefore P2 is equal to P1V1 over V2. So just substitute the values. Okay, 49.753 times 0.5 over 2 liters is 12.438 atmospheres. So the actual question is calculate the pressure change due to the expansion. So the pressure change due to the expansion should be negative, because if you expand the gas, the volume increases, but the pressure decreases. That's according to Boyle's law, especially this is a system that is isothermal. So the delta P is 12.438 atmospheres minus 49.753 atmospheres, which is the initial pressure. You'll get the negative answer of 37.315 atmosphere. So the pressure is decreased. Okay? So next problem. Two gases, O2 and N2, were placed inside a 2-liter container at 30 degrees Celsius. So if the total pressure is 12.438 atm and the total mass of the gas mixture is 29.5 grams, calculate the partial pressures of O2 and N2. So for number 1, or if we'll do this step by step, first we will calculate the number of moles of the mixture. So using PV equals nRT, this is N equals PV over RT. So you'll get the number of moles of the mixture. This P is the total pressure of the mixture. Okay, so getting the N, 12.438 atm, that's the total pressure of the system here. 2.00 liters is the volume of the system. 0.082606 is the gas constant. 30 plus 273.15 is the temperature of the system in Kelvin. So you'll get 0.9999803.429, or almost 1 mole. So calculate the molar mass, or the average molar mass of the mixture. So we've learned that the average molar mass is the mass of the mixture, okay, over the moles of the mixture. So the total mass over the total number of moles. So the total mass over total number of moles is 29.50 grams per mole. So we get the average molar mass. So the next thing to do is to calculate the number, or the mole fractions of the components based on the average molar mass. So the equation for the average molar mass is this one. Okay, the unknowns here are yung mole fraction of O2 and mole fraction of N2. Okay, so to get the mole fractions, we have this relation. The mole fraction of N2 plus mole fraction of O2 is equal to 1. So therefore, the mole fraction of N2 is equal to 1 minus mole fraction of O2. So we'll just have to substitute the 1 minus mole fraction of O2 to the mole fraction of N2, so that we have one variable. So solving for O2 and N2 using this equation, okay, ito na yung ginamit nating equation after the substitution. So ang unknown na lang natin dyan ay yung O2, okay, yung mole fraction ng O2. So solving for the O2 and N2, the mole fraction of O2 is 0.375 and the mole fraction of N2 is 0.625. So solve for the partial pressures of N2 and O2. So the PO2, or the pressure of O2, is equal to the mole fraction of O2 times P total. The pressure of N2 is equal to the mole fraction of N2 times P total. So this is based on the equation. The mole fraction of component I is equal to the pressure of component I over the P total. Okay, therefore the chi I P total is equal to P I. That would be the case for both gases. So using those equations, 0.375 times 12.438 atm will be the pressure of O2, that is 4.644 atm. For N2, that's 0.625 times 12.438 atm, that is 7.774 atm. So those are the examples of the problems related to the partial pressure and the average molar mass. So see you next video.